if you're just optimizing your model performance, it's like you're doing hit and trial without even understanding the science behind it. Hello, how to think statistically, or how to look at a new data set with a proper framework. Now, whenever you look at a new data set, there are a few questions which you need to ask. Now, the questions could range from whether the data is really clean in the sense that do we have proper columns and rows, and do we have proper naming conventions about the data, meaning data dictionary, do we know the meaning of all the columns and all the rows, and do we have an idea that if we have missing values or any observations, what is the interpretation of that. If we do not have, then we need to go to the next stage, and if we have, it's good enough, we can do some kind of an imputation on them. And if we do not have information, then also we can have some further round of imputation, or maybe just removal of those observations which do not have meaningful values, or which have a lot of NA values or empty values or missing values. So this is the first stage of your statistical thinking or analysis of data. Now, when you move to the next stage, you need to think about what questions are being asked to you, or what questions you need to ask from the data. Now, the questions could, as I said, could come from outside, somebody giving you a data set and giving you an unstructured or a structured problem set, or it could be your personal exercise that you have a task at hand and you are trying to get a grip on various data sets. So if the question is of a structured nature, either it's a classification problem or a regression problem. Now, when I say classification problem or regression problem, you do not need to be scared about those things. I have already made few lectures on econometrics, and in those lectures, the first few lectures are based on regression. And about classification is pretty simple in nature. Don't get into the nitty-gritty of it, but classification is kind of like, let's say I want to predict whether someone is healthy or not, dependent upon various factors. Now, that is a classification problem. Now, obviously, this is a very simple sort of a classification problem, but you get the drift. Now, this was a structured problem. Now, let's say you have an unstructured problem. Let's say a company comes to you, or a client comes to you, or let's say a party comes to you and says that, look, I need to optimize this, and this is the data set. Now, whenever you have to optimize something and they have given you a data set, you have to first think about how do I optimize that, what kind of a problem do I have to make. Now, a very simple way to think about it, it might not require statistics at all. It could have a closed form mathematical solution, something like your simple optimization exercise of calculus, or maybe linear programming problem, or convex optimization, or anything which has a closed form solution. Now, the other way is the statistical way. Now, if you do not have your mathematical means to drive home that problem, you have to build a statistical problem, a structured statistical problem. Now, over here, as you keep on learning more concepts, as you keep on analyzing more data sets, you will have more clarity on how to go from an unstructured problem to a structured problem with statistics. Now, the third type, the problem which you are having with you and you are looking at new data sets. Now, whenever you already have a problem with you, it could be because it has been driven down from a structured problem to your problem, or an unstructured to structured to your problem, because your problem will be different than the structured or unstructured problem, because your problem will be more focused in nature. You will be wanting to know something very deep, very critical to your modeling exercise or analysis exercise, which will give you direct solutions. Now, when I say direct solutions, obviously the solutions will have some kind of an error, some kind of an accuracy, and all those statistical parameters, which we call them like model performance or solution performance, as the name you want to give them. But the idea over here is that whenever you have your own problem statement and you're looking at a data set, the few things which you need to do is first understand the nitty-gritty of data, have your own data dictionary. What is the idea of these columns? What do they mean? Do you need to impute few columns, or rather, let's say, make few columns out of these? And do we need to remove or insert few rows into it? And do we need to do some kind of an exploratory statistical analysis, rather inference analysis, or any kind of an exercise which we do for your model building exercise, but not the model building? Now then you move to the model building, and after first doing the exploratory exercise, then model building, then you check the model performance. Now each of these steps must also be preceded by some kind of a statistical background. So obviously, if you do not have that statistical background, you might not have an efficient or a conceptually sound way to have those steps performed. So once you have performed those steps, you will have a final model performance. Now that model performance can drive you back towards your problem, and you can reformulate it, get more data sets, and have more statistical analysis and make a different model. Now this is kind of a cyclic process, and a lot of people try to use the model performance as restructuring their entire problem. But I say, do not think in terms of model performance, think in terms of your statistical assumptions. Because whenever you think in terms of your statistical assumptions, it is like prevention is better than cure. Now if you're mindlessly applying statistical or machine learning models to data, it will give you some kind of a model performance. And if you're just optimizing your model performance, it's like you're doing hit and trial without even understanding the science behind it. So do not do that. Try to understand the approach and the statistical assumptions, and then only go ahead with a model and check its performance. And if your assumptions and performance are in sync with each other, then you are good to go. But let's say your assumptions and model performance are not in sync with each other, then you need to tweak your assumptions and then check the model performance. And when I say tweak the assumptions, it's not hit and trial, it's based on your analysis. It should have some kind of a statistical backing. Whenever you change an assumption, you need to have strong reasons to change your assumption. So that's the idea. Now yes, obviously this video is not a very structured video, or I should say a kind of a one size fits all framework. This is more towards developing your thinking, because I remember in one of my videos somebody had asked that how to develop statistical thinking. Over there I did not have a real way to answer that, because this is really not something which can be written or said in a how to format or given a prescription for. So yes, I'm not trying to give a prescription for how to think statistically, but still I'm giving it a try to implore you that your statistical thinking requires a good understanding of statistics and a lot of data sets. So whenever you have time, download data sets from any data source and read a bit of statistics every day, and try to apply your statistical concepts in data sets. And when you do this regularly, your tools should not be your hindrance over here. Use Excel, R, Python, Julia, or anything. And when you go through these stages, you will automatically understand which statistical concepts you need to look at, which modeling examples you need to cover, and then you'll automatically have your own statistical thinking process developed. Now this is my idea, and this is my takeaway from this, and this is something which I wanted to share with you guys. So if you want to be updated with more content on statistics, data science, mathematics, economics, and finance, don't forget to subscribe to this channel and also press the bell icon.